Alright, so this problem was super long and crazy, and I can't believe I put in this foldable because it does not fit. So I just scribbled it out and decided we're not going to do it. So let's move over here to this one, which is much easier. We're going to find the derivative with respect to t for y equals 2 over t. So notice which type of notation do we need to use. This is a y equals, so we're going to use this type. So we're going to do the derivative with respect to t. So we'll start out with dy over dt equals, and we need to remind ourselves of the limit formula, which is up here. So I need to start, or the derivative formula, I need to start by putting our limit notation. So it is the limit of, and then we need to do this f of x plus delta x right here. So we're going to plug that in for our t. So remember, it's going to be a little weird, but our variable is actually t here. So we're going to write 2 over t plus delta t. And then it says subtract f of x. So we're going to subtract our function right there. And then it's all going to be over delta t. So what we have on our hands is a complex fraction. And again, I don't have much room for this in my foldable, so I guess I just need to suck it up and finish it inside the ISN. So that's what I'm going to do. So we have plenty of room. Okay, so here we go. We've got a complex fraction. So first we need to combine the fractions in our numerator. And so we're going to write that as dy over dt equals. And to get common denominators, we have to multiply by the other denominator. So this first fraction will become 2t over t times t plus delta t. And the second fraction will become 2 times t plus delta t all over t times t plus delta t. And then all of that is over delta t. So it's kind of a mess, but it will work out. So now we're going to combine our fractions on top. Oh, and I forgot my limit notation. Shame on me. As delta x approaches 0. Okay, so combine those fractions on top, and we get dy over dt equals the limit, as the change in x approaches 0, of 2t minus 2 times t plus delta t. That's my numerators, over my denominator, which is t times t plus delta t. And I'm going to go ahead and do my stay switch switch. This is my top, it stays the same. Division becomes multiplication, and I flip the bottom fraction. So it still doesn't look too promising, but we're getting there. We need to distribute this negative sign, and notice that we're going to end up with, well, let's write our new notation. dy over dt equals the limit, as delta x approaches 0, of, and notice this 2t is going to be subtracted by a negative 2t. So those will cancel. And all we'll end up with is a negative delta t over t times t plus delta t. And then it's multiplied by 1 over delta t. These guys will cancel. And we can actually evaluate our limit by plugging in the 0 for our delta t, and these should be t's. Hopefully some of you noticed that. And so we plug the 0 in here, and we will get our derivative, dy over dt equals 1 over t squared. And there it is. Voila. So big mess, Your job is basically to simplify it, and then you're going to end up with your derivative. And at this point, if you wanted to find the slope now, you would just say, what point? What t value do you want me to find the slope? And you can do it.